Okay, so now that you've seen that a cone takes up exactly a third of the space of a cylinder, basically we can just treat it, and when we're trying to find the volume of a cone, we can first look at it as though it was a cylinder and then just simply take that volume and divide it by 3 or multiply it by 1/3. I use those two expressions interchangeably, multiplying by 1/3 or dividing by 3. We're going to do that whenever we're changing the volume of a cylinder into the volume of a cone because we know that it takes up a third of the space. And same for a pyramid. A pyramid takes up the third of a space of a prism. So that number 1/3 or divided by 3 are really the only difference between the pyramid and a prism or a cylinder and a cone. All right, so let's go ahead and use that information to go ahead and find the volume of this cone and the volume of this pyramid. Okay, so again, thinking of this, if this was a cylinder, there would be a circle on this side and a parallel circle to it up here. The volume would equal to the area of that circle, which is pi r squared, all right, times one more dimension, and this is an interesting one, which is the dimension that runs right between those two perpendicular to it. Well, this one is not perpendicular to that. We need to use the perpendicular one. So don't use the 8. It's definitely the 9 inches there. So we're going to do, we'll call that the height. Volume equals pi r squared times the height. But remembering that the volume of a cone is 1/3 of the volume of a cylinder. The only thing we have to do to change when we're finding it is make sure we divide by 3. Again, you can multiply by 1/3 or divide by 3. I like writing it as divided by 3. So I've got pi times my radius squared. My radius here, actually the diameter they give me is 5. So the radius is half of that, which is 2.5 squared, times the height here, which is 9. That whole number divided by 3. And my calculator gives me 58.9 cubic inches. Okay, moving on to the next one here. Now I'm going to find the volume of a pyramid. Again, a pyramid is basically very similar to the shape of a prism. A prism was basically the area of the bottom times one more dimension, except we're going to divide it by 3. All right, so I have the area of one of the rectangles here, which is, so the volume is going to equal to, in this case, the area of the rectangle at the bottom, which is width times length, times one more dimension, which in this case, the perpendicular dimension is the height. All right, and then don't forget we're going to divide that by 3 because it's not a prism, it's a pyramid, which is 1/3 of the volume. Okay, so then I do 8 times 7, which is the area of the rectangle, times one more dimension, which is the height, and then I divide that by 3, and my calculator gives me 205.3 cubic centimeters. So many items in real life are made up of more than one type of solid, so sometimes we need to add these up here. For instance, in this particular building here, we have 2 different shapes in here. One of which is, if we look at this bottom shape here that makes up the bottom part of the house here, it's got 24 by 24. It actually has a square on the bottom, which means it's going to be a square prism. And in fact, because it has the same height dimension, it actually is a cube. So 24 by 24 by 24. So this is a cube at the bottom. We'll call it, we might as well generalize and call it a rectangular prism for right now. But the volume of that is, again, we would find the area of, actually, let's write this in 2 different steps. We will write this as the volume of the rectangular prism. And then the top part, the roof part here, is actually a rectangular pyramid. So a volume of rectangular prism. Now we're going to add, since we're the volume, the space that this takes up, adding up with the volume, the space that this one takes up will give me the total volume. So we'll put in here rectangular pyramid. Okay, so to find that volume of the rectangular prism, in this case here, is going to give me 24 times 24 times 24. That's the cube that's in the bottom there, plus the rectangular pyramid. The rectangular pyramid, again, has a square on the bottom. Okay, the area of that square, which is again, 24 times 24. A lot of students miss that. We've got those still are 24 because they're perfectly parallel to the bottom parts of that cube. Times one more dimension, stretch it up one more dimension, has to be the one that's perpendicular to it, which is the height, not this slant length there. So we're going to call that, so that's the height, which is 15. And again, a pyramid takes up only a third of a prism, so we need to make sure that we divide it by 3. So then I throw that in my calculator, and I get 16,704 cubic centimeters. Okay. So again, it's a complex solid. I just simply add up the volume of one with the other one to be able to get my answer here. All right, one last problem here. We're looking at the area of the Pyramid Arena in Memphis. And in this case here, if we look at a pyramid, we know again that the volume of a pyramid is equal to the area of the rectangle on the bottom. So I'll write that down, area of rectangle. Times one more dimension, which is going to be stretched up over the height, which is the perpendicular dimension to that face. And because it is 1/3 of a prism, we are going to divide by 3. Okay. So in this case here, interesting thing about this is they give me some different information in here. They actually give me the volume, and they want me to find the height. So the volume in this case here, I'm going to plug that in for V, is 38,520,000 cubic feet, is equal to the area of the rectangle, and that's what they tell me here. The area of the base pyramid arena in Memphis is 360,000 square feet. Okay, so there's 360,000 square feet times the height divided by 3. Okay, so I have everything but h. Now I have to solve for h. How is h not by itself? It's being multiplied by 360,000 and it's being divided by 3. All right, so I'm going to do just the opposite. I'm going to divide, I'm actually going to multiply it by 3 and divide it by 360,000 from both sides. All right, so we're going to multiply by 3, divided by 360,000 on both sides. Okay, so if I take in my calculator, I'm going to multiply 38,520,000. I'm going to multiply that by 3 and divide that by 360,000. And I get 321. So my height is equal to 321. And this is a single dimension. In this case here, we're talking about feet. This is 321 feet. So 321 feet is the height of the arena.